In the last lesson, we built this rather powerful generic HTTP request function, and now in this lesson, we'll make use of it calling the Allergy API from the Medicine University of Vienna. So to get started, we'll make a new folder called Allergy API and a new Go file, allergy_api.go. And this package is the same as the folder and file name, allergy_api. And now the first thing we need to do is define the types that we will pass into our generic function here so that the JSON here, when it's unmarshaled, knows the type it should unmarshal into. And looking back into those two separate API calls, we have our hourly load data, which has kind of this overarching structure with the success and result keys. And then within the result, we have another object, which has a total, some sort of personalized option, and then most important for us, the hourly array, which is an array of integers. For the get current chart data, we also have a similar structure. We have a large object, which has the success and result keys, but then the results here is directly an array with a repeating object that has date, current, average, season, and date time. And once again, most important for us here is the average. We're going to take this endpoint for the historical average portion of the message that we send out. So let's get started with the hourly load data types. So first I'm going to define the response, and that has a success and result key here. So I'm going to define this as hourly load response. This is a struct, and we have our success, which is an int, and the JSON identifier here is lowercase success, and the result, which we'll need to define a new type, a new struct for this nested type. I'm going to call it hourly load result. And we also need to define the JSON key that is lowercase result. And now, since this type uses this other struct, I typically like to put the type above here. And what do we have? We have the total and the hourly. Total is an int, JSON lowercase total, and hourly is a slice of ints, and the JSON is hourly. And when I save here again, the linter is formatting everything nice and neat into columns. Now we can move on to the chart data. So similarly, we have the chart data response. And let's take a look at this. Also, success and result keys. So success is an int, and the result, or I should say results plural, is an array, and this type will need to be another custom type, which I'll call current chart data result. And we also need to specify the JSON key. So I'll take this and define the type here. And all we really need is the date, which for now we'll take as a string, and the average, which is a float. So we have date and the average. I can save this, and that should be all we need for custom typings. Now we'll write a separate function for each API endpoint. The first one we can call get hourly load data. And the second we will call get current chart data. Now for both of these, we expect that they return a string pointer and an error. And this string will be ultimately the message that we'll pass on to our Slack messenger. And we know the goal here is to call our generic function here. So we'll have a response and an error from, can import this utils package that we've just created in the previous lesson, and the make HTTP request. Now we don't need to specify the type explicitly. Golang will infer that for us. And for the URL, we have it here. That's this index.php. We can put that in. We know this will be a GET request. We don't need to pass any headers. We will need to pass some query parameters. There's no body that we need to pass. And the response type is the hourly load response. And if the error is not nil, we'll return a nil string and the error. And for now, let's move into these query parameters. This type is the URL values. And we can add all the parameters we need. So there's quite a few here for this hourly. We've got an EID, an action, type, can provide a zip, country, and so on. So we'll provide all those query parameters so we're sure that our GET request functions exactly as it does in the browser. So we're going to add this EID, the type is zip, the zip is 6,800. The country is Austria, AT. And there's also this flag for the pure JSON, and that is 1. Can import this URL package. And now let's move on to formatting and building this string that we want to return. So from the data here, we have the full array of the hourly load expected. And so what we'll do is loop over this array, build an average, and then create a string that mentions what this average is. So we'll first define some average load. And then we're going to loop at the range, which we know is within the hourly part of the result. So that's just plus equals the hour value. And then the average load becomes the average load divided by the length of all the hours. One other thing I've noticed from looking around the API is that they're doing some sort of normalization of the data. It's not shown here, but these numbers can go as high as 8 or 9. but they only show a ranking from 0 to 4 on the actual UI of the website. So for now, to kind of mimic that functionality, we are going to just divide the average, we'll call it a scaled average load, and that will just be this average load divided by 2. The formatted message that we'll send, we'll take the format package, sprint F, and we'll say the average pollen load for today is scaled average, and we will return that formatted message and no error. The implementation for get current chart data is quite similar. I'm actually going to copy all of this and then we can make changes accordingly. And I've made a small mistake here. This is the action key, and the EID is in fact app interface. We can add that in here. Now here in this case, the action is, as we can see here in the URL, is get current chart data. The poll ID, this is actually for the type of plant. In this case, I've made it for my allergy, which is for grasses or hay. We can still pass the zip. We only care about the season data, and that's the flag for the in-season data. And we also want that pure JSON flag to be activated. The URL is the same, the method is the same. We still pass, of course, the query parameters, and now we just need to change the response type, which is the current chart data response type. Now, of course, Go will complain here because the shape of the response is different. So what we want to do for this method is to loop at all these results until we find a matching date, and then we want to print the historical average for the current date. So I'm going to define a variable called current YYMMDD. That's time.now. And then we need to format it using the Go style of formatting strings. We'll define an average historical, which will initialize as 0, and then we'll loop over those results and find the matching date. So if the result date equals this current date, then we know that the average historical is that result average. And similarly, as we did above, we should create a scaled average. And we'll take a int cast of that since we only want 0 through 4. And we're just going to round the average historical found divided by 2. And then we can create our formatted message. And in this case, we'll say historically, the average pollen load for today is, and we'll pass in that scaled average. We save, the linter will import those packages, and we should be all set. So in this lesson, we got started thinking about how we can call these two endpoints and deserialize the JSON that they return. We started off by looking at the structure of the JSON and defining the needed types and the needed parts of that JSON that we need to use for building our messages. We then started writing the actual functions that call the endpoint, making use of our make HTTP request that we built in the previous lesson. Once we get the response, we do a little bit of calculation and formatting, and for each function, we ultimately return the formatted string, which we'll be able to send through Slack. In the next lesson, we'll take this return string and send it through Slack via webhooks.